NASA has just revealed what they're calling the clearest sign yet of ancient life on Mars. For decades we've wondered, did the red planet once host living organisms? And now, new evidence buried inside a Martian rock may finally bring us closer to that answer. For billions of years, Mars has held its secrets close. But in the vast, silent expanse of Jezero Crater, a place of profound scientific promise, humanity began to listen. This crater wasn't always a dry, windswept basin. 3.5 billion years ago, it was a deep, tranquil lake fed by a winding river delta. Orbital scans had long hinted at its potential, revealing clays and carbonate minerals, tantalizing signs of a past that could have supported life. It was here, in this ancient, aqueous environment, that NASA's Perseverance rover, a sophisticated mobile laboratory, was sent on the most ambitious search yet for Martian biosignatures. The rover's mission zeroed in on this peculiar formation. With surgical precision, Perseverance extended its robotic arm, first abrading the surface to peer beneath millennia of dust and radiation damage. Then, its rotary percussive drill whirred to life, boring deep into the rock to extract a pristine core sample, a precious cylinder of Martian history, sealed away for a future journey to Earth. What lay inside this 3.5 billion-year-old rock was an astonishing convergence of clues. Analysis by the rover's onboard instruments, including the Sherlock spectrometer, revealed not just the presence of carbon-based compounds, the fundamental building blocks of life as we know it, but their specific location. They were found alongside sulfur, phosphorus, and oxidized iron. This wasn't a random jumble of elements. This was a collection of the very same chemical ingredients that fuel microbial ecosystems here on Earth, found together in a place that once held water. And the mystery deepened. The instruments mapped strange, circular features within the rock, nicknamed leopard spots. These nodules were enriched with both organic molecules and specific minerals, including vivianite, a hydrous iron phosphate. On our own planet, vivianite is often formed in waterlogged sediments and is known for its remarkable ability to preserve delicate organic matter. The presence of iron sulfides like greigite further electrified the science team, as these minerals are frequently linked to the metabolic processes of sulfur-reducing bacteria in oxygen-poor environments. While not definitive proof, the pattern was undeniable: a habitable ancient environment, the raw materials for life, and mineralogical clues that on Earth point directly to biology. But the strangest find: tiny nodules across the rock, nicknamed leopard spots. On Earth, these patterns are often linked to microbial colonies that leave behind chemical fingerprints in sediments. Could these spots be Mars' ancient microbial graffiti, a sign that life once thrived here? NASA also detected minerals like vivianite and greigite. On Earth, these minerals often appear in places shaped by microbial metabolism. Imagine tiny Martian microbes once feasting in shallow waters, leaving behind a mineral record that survived billions of years. But here's the catch: none of this is absolute proof. The signals are tantalizing, but they don't yet add up to a definitive discovery. To make such an extraordinary claim, scientists have a rigorous checklist known as biosignature criteria. This isn't about finding one single smoking gun. It's about the convergence of multiple lines of evidence, specific chemicals, distinct minerals, and suggestive textures, all found in a geological context that once could have supported life. Every piece must fit. The reason for this extreme caution is that Mars is a master of disguise. These features could, in theory, also form without life through rare chemical reactions. For nearly every sign pointing to biology, there's a potential non-biological imposter. Intense hydrothermal activity can create complex structures. A process called serpentinization can react water with rock to generate simple organic molecules. Even reactions spurred by the planet's harsh radiation can mimic the signs of life. These are the abiotic mimics, the geological ghosts that haunt the search. This is why a single clue is never enough. The ambiguity is too high. The absolute key is context. Are these organic molecules found inside the mineral structures that suggest a watery past? Are they located in a specific geological layer, the stratigraphy, that aligns with a time when Mars was habitable? This principle of co-location is non-negotiable. Without it, we can't distinguish a potential fossil from a geological accident. It's the difference between finding a single brick and finding that brick as part of a ruined house's foundation, and that is precisely why NASA is being so careful. They're not declaring life just yet. Instead, they're meticulously building a case. What makes this discovery so significant isn't one piece of data, but the accumulation of them in one place. The convergence of clues is what makes this the strongest case so far, stronger than any hint we've ever had. It's a powerful signpost, pointing us in a new direction, and it underscores the absolute necessity of bringing these precious samples home for the final verdict. The real breakthrough may come when these Martian rocks are returned to Earth. Powerful laboratories here can analyze them in ways no rover ever could. If microbes once lived on Mars, Earth scientists may finally confirm it in the coming decade. So, did life truly exist on Mars? For generations, this question has echoed through our imagination. We have now moved beyond merely following the water to a more profound phase of exploration, scrutinizing ancient habitable environments for the inhabitants themselves. We stand at a threshold, peering across billions of years of silence, and the data from Perseverance represents this pivotal moment. What the rover has uncovered is not a single, ambiguous clue, but a compelling mosaic. It's the right carbon-based chemistry, found within the right life-friendly minerals, all embedded within rock textures that hint at biological influence. While non-living geology could explain each piece individually, their perfect co-location is what makes this the strongest whisper ever heard from another world. It's a complex, structured signal that has waited eons to be read. Confirming this signal would forever alter our place in the cosmos. If life arose independently on two adjacent planets, it would suggest that biology is not a miracle, but a fundamental property of the universe, a common outcome of planetary evolution. This realization would electrify our search for life elsewhere, turning our gaze with renewed purpose to the hidden oceans of Europa and Enceladus, and the countless worlds we are discovering around distant stars. The final verdict, however, remains locked away, millions of miles from Earth. The ultimate answers will not come from the rover, but from the samples it has so carefully collected. The Mars sample return mission is the critical next chapter, our only path to turning tantalizing possibility into undeniable proof. The red planet has held its secrets close for eons. But as we prepare to bring a piece of it home, we stand on the verge of a revelation, a chance to finally answer one of humanity's oldest questions. Your turn. What evidence would convince you? Comment your take below.